So for the week 3 homework screencast, I wanted to address a couple things regarding this electric compass that I made. It might be a little bit hard to see, but here we have the tape hanging, and then we have the PVC rods and the suspended from a string paperclip. The tape is. It was amazing how well the tape seemed to keep a charge, but again, apparently the humidity maybe was low when I was doing this a couple days ago. And then a couple parts of the lab, I had trouble finding the results that I knew were correct. Now that brings up an interesting point, because for students who might be doing this lab early on in the unit to describe electric fields, they might not come away with the sort of correct ideas regarding directions for electric fields. If, for example, humidity is high, they're not getting much of a response, or the tape is moving quite a bit. I think that, the students would definitely have to be sort of mentored and have this device sort of modeled for them. So that when they do their own, they kind of understand that, okay, well, I guess the mass should not be very high for the hanging tape. Otherwise, that might affect the motion of the tape, as well as, understanding sort of how close we're talking about when we talk about bringing the tape close to the lucite rod or the PVC rod that's charged. And a couple times in the lab, the tape actually touched the rods, but really it didn't seem to be affected too much by it, because it still kept the proper charge that I was hoping for. But that could also be another sort of error, I guess, where the students might be getting some misconceptions. I think in light of the other activity, the alternate activity, and I didn't do this electric compass, this mapping electric fields lab in its entirety. But I did do the PhET simulation, the whole thing. And I think, and that was, that's fairly clear. It's a simulation, so it's not that dynamic as far as, students being able to test out various scenarios quite as much, maybe. But it was very useful because, students could go back and redo something and not have to worry about, if the tape lost its charge, then they'd have to, go back, recharge it, and they'd be worried maybe about, getting the right charge on it and such things, because, it is a little bit sort of maybe difficult to make sure you don't touch the tape and sort of cause it to ground. But the PhET simulation was real good. And so I'm thinking maybe the PhET simulation first for students to explore, so that they have some idea of maybe what they should be seeing when they are going ahead and doing the more hands-on electric compass lab, the mapping electric fields lab. Now that's debatable, I guess. I have not done either of these activities with my students in the past, with the electric compass or with the PhET simulation. But I know there's more PhET simulations regarding electrostatics and also, current and circuits. So I'm really interested in sort of exploring them. One limitation at my school, the computing facilities and the computers that we have available to us are not the best and the most reliable. So that is an issue. And some of our machines that are running, they don't even run PhETs because we can't get various plugins installed. So anyway, that's frustrating. But this activity definitely is useful. It's very interesting, and I'm excited to use it as part of my arsenal, I guess, for getting kids to sort of explore and work through some ideas rather than just being given the information, for example. So it fits much better with the modeling method of instruction. And so I guess that's all I'm going to say about that. Thanks.